All right. So in this lesson, I'm going to explain to you how to draw a box and whisker plot. But before we actually start drawing it, it's good to actually do a quick recap of the previous lesson where I showed you how to work out the different quartiles. And in this video, I'm going to actually introduce a quick trick you can use to actually locate the median. So you'll see on the screen that we have three different quartiles written here. The first one is Q1. So Q1 stands for the lower quartile. Q2 is the median, so the middle of the data set, and Q3 is the upper quartile. Now, there is a trick you can use to locate the median through calculation, and that trick is actually written on the right hand side here. So if you have an even number in the data set, so here we have 10 numbers, that's an even number. To locate the median, you can actually do 10 plus 1 divided by 2. So if the number is even, you can do n plus 1 divided by 2 th, because that gives you a rank, and this is where the median will be found. So if you have an even number like 10, 12, 14, 16, you can just do plus 1 divided by 2. So here it's 10 plus 1, 11 divided by 2, it's the 5.5 number. So 1, 2, 3, 4, 5. 5.5 is between 5th and 6th number. So this is why we initially did 15 plus 18 divided by 2. But last time I didn't show you a formula because I wanted you to actually visualize how this number here splits the data set into two equal halves so that you have the same number of numbers on the left and right hand side. Because if this is the median, then I have 1, 2, 3, 4, 5, 5 numbers on the right, and 1, 2, 3, 4, 5, 5 numbers on the left. All right. So if you have an even number, plus 1 divided by 2, that gives you the median. And if you have an odd number, there will be exactly a number there whereby you'll have two equal sets of numbers around that median. All right. So that's a quick formula you can use if you have an even number. Now, in the previous lesson, we already went through how to calculate the lower quartile, median, and upper quartile. Today, I'm going to show you how to put that information on a scale first, and then draw a box and whisker plot from that data. So if you need to draw a box and whisker plot, you first need the quartiles, and then you need the lowest value of the data set, which is 4 here. So in case your number is not in ascending order, that's the first step in your workings, whereby you write the number in ascending order and then you work out the quartiles, because all these ranking formula won't work if it's not in ascending order. So here the lowest number is 4, and the highest value is the last number, which is 35 here. So basically I need to fit the data on the number line so that you can include 4 and 35 in it. All right, there are many ways to do it. You can actually start with 0, and 1 square can be 5. Okay, you decide. So if I consider 1 square to be 5, I have 5, 10, 15, 20, 25, 30, 35. Then my box and whisker is going to end here, which gives me quite a restricted box if I have to draw it. So 1 square for 5 units is quite restricted. What if we choose 2 squares for 5? So then I'll have 5 here, 10, 15, 20, 25, 30, 35. So if I use 2 squares to present 5 units, I kind of get quite a good spread so that I can actually draw a proper box here. So you can do it by trial and error till you get something which is reasonable, and you can actually draw by hand, because we're not using technology to draw it here. We're using, pen and paper. So once we've got the scale figured out using common sense, like we just did here, then we can fit in the numbers. So 4 is the smallest number. So you would be doing that on a graph paper basically. So 4 would be somewhere here. Then the lower quartile is 8. So 8 will be somewhere here. Okay. Now, where the lower quartile is, that's where the start of the box is drawn. So that's why you see that I'm drawing actually a line here, because that's the start of my box. And then the median is 16.5. So 1 square is 5 units. Sorry, 2 squares was 5 units. So 1 square will be 2.5. So here you have 15 plus 2.5, so that's 17.5. 16.5 will be somewhere here. All right, it's a bit approximate, but we try to use logic to actually fit in these different points. And then Q3 is 24, so that's just before 25. That's my Q3. So the box starts with Q1, it has Q2 in the middle, and then it has Q3 here. And then the highest value is 35, so we're just going to put a dot here. So the smallest value is a dot, the highest value is a dot, the lower quartile is where the box starts, the upper quartile is where it ends, and then you actually just join so that you do create a box. And then from the upper quartile till the highest value, you draw a line. And then from the lowest value up to the lower quartile, there's another line. So that's why it's called a box plot or box and whisker diagrams, because you have the box and then you have the whiskers. All right. So that's how you draw a box and whisker diagram. Now, once we were able to draw the box and whisker plot, there are a couple of things they can ask us. And one of the things they can ask us is they can ask us about the shape of the diagram. So you see from your notes that it mentions about positively skewed box plot and negatively skewed box plot. So the positively skewed box plot has a bigger distance from the median till the highest value, whereas a negatively skewed box plot has a bigger distance from the median, so from Q2 till the smallest value. So visually you could actually determine whether it's a positively skewed or negatively skewed box plot, but we can actually do it through workings also. So we know that Q2 is 16.5. So if I do 35 minus 16.5, I get 18.5. So that's the distance from the median till the upper quartile. It's 18.5. Then if I calculate the distance from the median till the lower quartile, so that will be 16.5 minus the smallest value, which is 4. That gives me 12.5. So the distance from here is 12.5. So we can see that there is a bigger distance from the median till the highest value. So in this case, it's a positively skewed box plot. Okay, so this is how we can determine it. We can do through workings. In some cases, we can clearly see that the till is longer to the right hand side compared to the left hand side. Even here visually you can determine it, but through workings it becomes more obvious that it's a positively skewed box plot. In a box plot which is symmetrical or normally distributed, you'll actually have the same distance from the median to the highest value and from the median till the lowest value. Okay, so in this case it's a positively skewed one.